This is the brainHatVIewer application. It can be used to display and record data from OpenBCI Cyton biosensing boards. The brainHatVIewer is used with the brainHat server, a program we wrote to enable easy plug-and-play lab streaming layer broadcast from an OpenBCI board. The brainHat server program runs in the background and waits for you to turn on your Cyton board. It will automatically connect and begin streaming data, as you can see when the red light comes on. Here we have the brainHat server running on a number of Raspberry Pi devices. Some are connected to a Cyton board and broadcasting real data. Others are playing back data from a file in simulator mode for this test. Since the command line on the Raspberry Pi is not everyone's cup of tea, we also wrote a version of the brainHat server program with a graphical user interface for Windows. Start up the program. If you do not see a COM port to select, make sure your dongle is plugged in and tap Refresh. Select your board type, your COM port, and tap Start Server. Wait for the board to connect. Then a few seconds later, you should see a new device available in the Viewer application. Double-click on any device to open the device details. To see a real-time plot of data from the device, select the filter you would like to apply and tap the button for the graph of your choice. There is a time series plot that shows the last few seconds of data from right to left. There is a sweep plot that shows the signal in an EEG-style viewer. And there is a band powers plot that shows band powers from 1 to 40 Hz. You can have multiple plots open simultaneously, each with a different filter applied. This helps you visualize the effects of different filter parameters. To look at unfiltered data, you need to use the automatic vertical scale. This is because the absolute values of each channel signal can be anywhere in the range of the sensor. Choose the detrend filter to normalize the signal around the 0 mark. You can use multifunction filters to apply multiple steps for the final signal you want. This 3-stage filter makes the data look similar to the OpenBCI GUI graph window. You can connect any number of servers at the same time, so you can view the real-time data from multiple devices simultaneously. Here we are connecting to and viewing the data from 4 different brainHat servers. We will speed this part up a bit while we arrange the windows for the 4 simultaneous data streams. Tap the View Data button to see a snapshot of the last few minutes of data. You can view the data snapshot without interrupting the live stream or any file recording in progress. You can scroll back and forth and select any point in time from the last few minutes of data. You can use the arrow keys to advance in fine increments. You can change the filter applied to the data and it will update to show you the new result. You can modify the vertical scale of the graph window. Remember, if you are using a filter that does not normalize around 0, you should use auto scale. You can change the time scale of the graph window to see 5, 10, or 20 seconds worth of data. You can start or stop recording data files on the brainHat server computer. These files are saved in OpenBCI GUI.txt format. You can open and view recorded files. Select a directory and the program will discover all valid files. When you are running the server and viewer on the same Windows machine, you can even open a data file for a recording session that is still in progress. Double-tap on the file to open it in the viewer, and you will be able to inspect data for the recording up to that point. Making sense out of EEG is all about the filtering. The brainHatVIewer program loads its filter parameters from an XML file, and you can even change parameters and reload your filters on the fly. Take a look at the default filter configuration file for the program. Starting with comments about the file structure and the brainflow filtering functions you can use, you will then see an element for each defined filter. A filter can use one or more of the brainflow data filter functions in sequence. You can add additional filters or change the parameters of any filter in the file. Here we cut and paste an existing filter element to modify its parameters and create a new filter. Save the file, and then you can reload the filter file in the brainHatVIewer application. You will notice your new filter is now available to use. The system is a work in progress, and there are still many things to do to be improved, but it does work pretty well. The brainHat server program is very lightweight. The brainHatVIewer program will make the fans come on when you have multiple graph windows open simultaneously, but it still works okay on my middle-of-the-road machine. Because the brainHat system uses Lab Streaming Layer, you can open as many client applications as you want to view and/or record the data streams simultaneously. For example, you can open our brainHat client application, a simple program we wrote to receive and record LSL data from a brainHat server. You can use any third-party application capable of receiving Lab Streaming Layer. Here we open Lab Recorder and verify it can see all the same brainHat server LSL streams. We also open the BrainVision LSL viewer, verifying it too sees the same streams. We can begin a session from any of these programs simultaneously. Now we are viewing and recording data using 4 different client applications at the same time. The source code for the brainHat system is available on GitHub in the BCI Beginner repository. There is also a document with more details about the system. The document includes instructions on how to build the brainHat server on the Raspberry Pi, a user guide for the client applications, as well as a link to a public folder where you can get installers for the brainHat client programs in case you don't want to build it yourself.